Now, if you recall, we started this module by taking a look at viewing the shared modules that were being used by various programs. And we were saying that these programs will use the shared modules so they can use then the shared code rather than having independently to build the code into each one of these programs. It just makes far more sense to use somebody else's code rather than reinventing the wheel every time we need access, let's say as we saw, to regular expressions. When we were taking a look at it, we used LDD and looked at usr/bin/bash. Remember, to see these library modules, we have to then go through and put the full path to the program. We could also go through and see the use of these modules using the process mapper. So using pmap, and here, if you want to look at the shell, if we're running a bash shell, we can go through and look at $, and this will show what everything in your own shell, the library modules that are being used. Having seen then the use of shared libraries, we could move on to looking at the location of these shared libraries. And we saw that they're going to be in directories like usrlib or lib64, usrlib64. We also looked at the fact that CentOS 7 does use symbolic links. So very often we would also expect a /lib directory and a /lib64 at the root of the file system. These exist in CentOS 7, but are just symbolic links, so we can use the one set of unified content. If we want to start creating our own directory structures, then we can use the ld.so.conf. But rather than just have a single configuration file, it is general in most Linux distributions, including CentOS 7, to use an extension directory. So we could then go through and add in our new locations within configuration files.conf files within the directory ld.so.conf.d. If we need to have independent locations to that which are provided by the system, such as for developers who are perhaps working on development versions of library modules, then we can configure our path through the variable ld_library_path. And of course, then this becomes very dynamic, as we can then go through and add to that path. We can also unset the path when we no longer want to use that variable. We had added in then our own library module, but to be able to use that library module, we need to then update the library cache. So the library cache file itself is a /edc/ld.so.cache. To read from this file, we can use ldconfig-p, and that can be run by a standard user. But to be able to write to that file to update that cache file, we have to run then the command ldconfig, and we run it as the root user. If we want to see actually what's happening when we go through and update it, we can run ldconfig-v, v for verbose, and this will then give us a printout as we're updating the cache file. So hopefully this is giving you a little bit of an idea of how the library cache works. Generally, software management tools are going to be updating the cache for us as the software is being updated, but at least it gives us some understanding so we can take a look underneath the hood should we need to try and fix errors that occur. But with our shared library modules done and dusted, we're going to take a little bit of a walk into scheduling tasks within Linux.